Let me start with a question that every software developer faces but rarely discusses explicitly. When you start building a new system, what do you do first? Do you spend time understanding the domain deeply, mapping out all the concepts, relationships, and business rules, or do you jump straight into building features that users can see and interact with? This might seem like a purely practical question, but it reveals something profound about how we approach software design. Today, we're going to explore what I call the great software design divide. Two fundamentally different philosophies that shape how we build systems, and more importantly, how we can choose between them intelligently. By the end of today's lesson, you'll be able to distinguish between ontology driven and requirements driven design approaches. Evaluate which approach fits different project contexts. Apply 5 proven integration patterns to blend both approaches effectively. Recognize the long term trade offs through concrete examples and design using concept based principles that anchor ontological models to real executable value. Now, let's deep dive into the first approach. The core philosophy of ontology driven design rests on a simple but powerful belief: software is primarily a model of reality. If you understand the domain deeply enough, the right code structure will emerge naturally. Think about this for a moment. Every piece of software we write is ultimately trying to represent some aspect of the real world in a computer. A banking system represents money, accounts, and transactions. An e commerce system represents products, customers, and purchases. A social media platform represents people, relationships, and communications. The ontology driven approach says before you start coding, first understand what these things really are. What is money fundamentally? What rules govern how it behaves? What is a customer versus a user versus a buyer? Are these the same concept or different concepts that happen to overlap? The process looks like this. You start by discovering the key entities, relationships, constraints, and state transitions that exist in the problem space. You work with domain experts to understand not just what the system should do, but what the domain itself should do. When you encode these discoveries as types, invariants, and state machines in your code. Now, let me give you a concrete example with payment processing. In the ontology driven approach, you would start by asking what is a payment method fundamentally. You discover that all payment methods share certain characteristics. They can authorize amounts, they can capture previously authorized amounts, and they have different refund capabilities. So you create an interface that captures this essential nature. You define that every payment method must be able to authorize a money amount and return some kind of authorization token. They must be able to capture using the token, and they must declare whether they support refunds. Now, when you implement a specific payment method, each one follows the same pattern but with its own specific behavior. A credit card authorizes by contacting the card network and checking for sufficient credit limits. It captures by finalizing the transaction. And yes, credit cards do support refunds. A digital wallet might authorize by checking the wallet's balance and placing a temporary hold. It captures by transferring the held funds. But here's an interesting domain insight. Some digital wallets don't support refunds because that money might come from gift card balances that can't be reversed. Now, assume that marketing comes to you in 6 months later and says, we need to support gift cards. Then you don't need to rewrite your payment processing system. You just implement a new gift card payment method that follows the same interface. The gift card authorizes by checking the card balances and placing a hold. It captures by deducting from the balance. And yes, gift cards can typically be refunded by adding money back to the card. Your existing payment service doesn't need to change at all. It already knows how to work with any payment method that follows the established pattern. The abstraction you created absorbs the new requirement completely. Now, this is the beauty of ontology driven design. When you model the domain accurately, new features often fit into existing abstractions without requiring changes to the core system. The key strength of this approach are profound. First, you get semantic clarity. Everyone on the team speaks the same language with precise definitions. When someone says authorization, everyone knows exactly what that means and how it differs from capture. Second, you get change absorption. New features often fit into existing abstractions, as we saw with the gift card example. Third, you get modular reasoning. Clear boundaries emerge naturally from domain concepts. You know that payment logic belongs in one place, user management in another, and order processing in a third. Studies have shown that systems built with strong domain modeling have 30 to 40% fewer major rewrites over a decade compared to systems that evolved organically. But this approach has significant weaknesses too. The upfront cost is high. Weeks or even months may pass before users see something working. The cognitive load is substantial. Newcomers must learn the entire conceptual map before they can contribute meaningfully to the code base. There's also the risk of over engineering. It's easy to model things that seem important but never actually matter in practice. And if your early modeling is wrong, refactoring becomes extremely painful because the wrong abstractions are embedded throughout the system. Now, let's explore the second approach. Requirements driven design operates from a fundamentally different philosophy. The only way to truly understand what users need is to build something they can use and provide feedback on. Architecture should emerge from real usage patterns, not theoretical modeling. This approach is grounded in a hard learned lesson from the software industry. We are not very good at predicting what users actually want. We think we understand their needs, but when they get their hands on working software, they use it in ways we never anticipated. The process looks like this: you start with a concrete user story. You build thin vertical slices through the entire stack, from user interface down to database. You deploy these slices quickly and gather real usage data. You let the architecture emerge from build, measure, and learn cycles. Using the same payment processing example, the requirements driven approach would start with a user story. As a customer, I want to pay with my credit card so I can complete my purchase. You're building the simplest thing that could possibly work. You create a checkout service with a method that takes a payment type string and a map of payment data. If the type is card, you handle credit card processing. If the type is UPI, you handle UPI processing. Simple, direct, and it works. When marketing wants gift cards 6 months later, you add another condition. If the type is gift, you handle gift card processing. The feature gets built exactly as requested, quickly and efficiently. The key strengths of this approach are compelling. You get fast time to market, working software in days, not weeks. You get real user feedback that validates or refutes your assumptions with actual usage data. You have low sunk cost. It's easy to pivot when hypotheses prove wrong. And stakeholders see immediate concrete progress. But the weaknesses emerge over time. You get semantic drift. The same concepts get different names in different parts of the system. Customer in one module, user in another, buyer in a third. You accumulate accidental complexity as each feature adds flags and conditionals that intertwine with existing logic. You get tight coupling as database schemas leak through service boundaries. And you face an increasing maintenance burden as entropy accumulates faster than you can refactor it away. Now, let me trace through a realistic sequence of feature requests that show you exactly how these approaches differ in practice. Both approaches start simple and work fine for basic credit card and digital wallets. Then, marketing wants gift cards. In the ontology driven approach, you add one new record type that implements the payment method interface. You define how gift cards authorize, capture, and handle refunds. That's it. Your payment service requires zero changes. All existing tests still pass. The refund logic automatically works with gift cards because they declare themselves as refundable. Now, in the requirements driven approach, you add another conditional branch to check for gift card types. You implement a new method with gift card specific logic, but it follows a different flow than the other payment methods. You update all your tests to cover the new branch. You update the refund logic to handle gift cards as a special case. You update reporting back to track gift card payments separately. Now, both approaches work, but notice that the ontology approach absorbs the change much cleaner. Now, assume marketing wants something more complex, split payments where customers can pay partially with a gift card and partially with a credit card. In the ontology driven approach, you create a composite payment method. It takes two payment methods and a split amount as parameters. When asked to authorize the total amount, it authorizes the specified amount on the first payment method and the remainder on the second payment method. When asked about refund capability, it returns true only if both underlying methods support refunds. Now, here's the beautiful part, your payment service still doesn't need to change. It treats the split payments like any other payment method. All existing payment methods automatically work in splits, gift cards with credit cards, digital wallets with bank transfers, any combination you can imagine. In the requirements driven approach, you add another conditional branch for split payments. You manually parse two payment methods from the request data. You figure out which type each one is and invoke the appropriate logic for each. You handle partial failures and rollback logic manually. You update refund handling to work with combinations of payment methods. You update reporting and analytics to track split payments. Your testing scenarios become much more complex. Do you see the pattern? The ontology approaches abstractions genuinely absorb new complexity. The requirements driven approach reacts by adding more conditional paths and duplicating logic. Now, this isn't to say that requirements driven is bad, it's optimizing for different goals. But it's crucial to understand these long term implications when choosing your approach. Understanding when to choose each approach is perhaps the most important skill you can develop. Let me give you clear decision criteria based on real project characteristics. Choose ontology driven design when you're working in highly regulated domains like banking or healthcare, where explicit invariants and rules matter enormously. These domains have well established concepts that change slowly, and the cost of getting them wrong is extremely high. Choose it for data centric platforms like analytics systems or knowledge graphs, where you're dealing with stable schemas and complex relationships between entities. The upfront investment in modeling pays off every time you need to add new reports or integrate new data sources. Choose ontology driven design for long lived systems with 5 to 10 year spans where the upfront investment will pay off over time. Choose it when you're dealing with complex business rules that interact in non obvious ways, the kind of domain where changing one rule has ripple effects throughout the system. And choose it when you have teams with domain modeling expertise who can do this kind of analysis effectively. I can give you a real success story. The UK government digital services saved over £2 million in Brexit related system changes because they modeled personas and entitlements early in their architecture. When complex residency rules changed, they could implement the changes by tweaking the rule definitions rather than rewriting code throughout the system. On the other hand, choose requirements driven design where when you are in an exploratory startup mode where product market fit is still unclear. You need to be able to pivot quickly based on what you learn from users. Choose it for short lived tools like migration scripts or internal utilities where the complexity will never grow enough to justify heavy modeling. Choose it in fast changing markets where the ability to pivot quickly matters more than long term maintainability. Choose it for simple domains with well understood stable requirements where the overhead of modeling doesn't provide much value. And choose it when you have teams that lack modeling expertise. Forcing domain modeling with inexperienced teams often leads to bad abstractions that are worse than no abstractions. A gaming startup called Shoot Off pivoted from trivia games to sports betting in just 9 months because they avoided heavy domain modeling that could have locked them into the wrong abstractions. Their requirements driven approach let them change direction quickly when they discovered where the real market opportunity was. Now, here's where things get really interesting. You don't have to choose just one approach for your entire system. There are five proven patterns for combining them strategically. The first pattern is core domain first. You identify the small kernel that every feature touches, except concepts like money, user, or time span. You model these core concepts carefully using ontological principles. You then build everything else using requirements driven stories that leverage the stable core. This works well when you can identify a stable core but expect a lot of peripheral features to be added over time. The second pattern is called concept cage. You place each major domain concept behind a service boundary. Teams working within a service use rich domain models. Teams consuming the service use simple request response interfaces based on user stories. This is perfect for microservices architectures where different teams own different domains with different levels of stability and complexity. The third pattern is delayed commitment. You use advanced language features like union types or refinement types to postpone concrete schema decisions until you have validated user stories with real usage data. You maintain flexibility without giving up type safety. This works when you are unsure about data modeling decisions but don't want to paint yourself into a corner. The fourth pattern is called executable specifications. You write property based tests that treats your domain model as a specification. Every user story must pass the same properties, ensuring consistency. You get the safety benefits of modeling with the flexibility of story driven development. The fifth pattern is socio-technical feedback loops. You schedule regular concept reviews alongside your normal backlog grooming sessions. You systematically review whether your domain model is still accurately reflecting how the system is actually being used and evolved. This prevents the model from becoming an outdated artifact. Now, let me give you a realistic scenario to practice making this decision. You're architecting a new e commerce platform. The business wants to launch in 6 months but expects the platform to run for at least 5 years. They're unsure about international expansion plans. Your current requirements include supporting US customers initially, credit card and PayPal payments, a simple product catalog with categories, basic user accounts and order history, and email notifications for orders. But there are significant unknowns about future needs. International markets will bring different tax rules, currencies, and payment methods. B2B sales might require bulk pricing, approval workflows, and purchase orders. Marketplace features could mean third party sellers and commission tracking. Advanced promotions like buy one get one offers, loyalty points, and coupon codes are all possibilities. Now, I want you to consider two different code approaches and think about which you would choose. Option A follows the requirements driven approach. You start with simple order controller that handles US specific tax calculations, by multiplying the subtotal by 8%. Payment processing checks if the payment type is credit card or PayPal and calls the appropriate method. Your product model has simple fields: ID, name, price in USD, string, category, and an integer stock quantity. This gets you to market quickly. You can have working checkout functionality potentially within weeks. Option B follows the ontology driven approach. You define payment methods as an interface that can authorize amounts and declare refund support. You create a tax calculator interface that different regions can implement. You design a pricing strategy interface that can handle simple prices now but can extend to tiered or bulk pricing later. Your order model contains rich domain objects with proper encapsulation and invariance. This obviously takes longer to build initially, but provides a foundation for complex future requirements. Now, here are the questions I want you to think through. Which approach would you choose and why? How would your decision change if the timeline was 3 months instead of 6 or 12 months instead of 6? What if this was a prototype versus a production system? How does team expertise affect your decision? What are the biggest risks of your chosen approach? Consider the timeline pressure. 6 months is tight. Can you afford the ontology investment? But also consider longevity. 5 years plus suggests that ontology benefits might pay off. There's significant uncertainty about international needs. Is early modeling premature or would it save you painful refactoring later? E commerce domains tend to accumulate business rules very quickly as you discover edge cases and regulatory requirements. How does that factor into your decision? Now, let me share some common mistakes I see teams make with each approach and, more importantly, how to avoid them. With ontology driven design, the biggest pitfall is over modeling, that is, creating abstractions for every possible future need you can imagine. I call this crystal ball programming. You're trying to predict every way the system might evolve and model all of it upfront. The fix is to apply the rule of three. Don't create an abstraction until you've seen the pattern at least 3 times in practice. This forces you to wait for real evidence before introducing complexity. Another common problem is analysis paralysis, endless modeling workshops without ever shipping anything. Teams get so caught up in perfecting their domain model that they never deliver values to users. Set strict timelines for modeling activities and require working prototypes early in the process, even if they're not built for the final architecture. The third pitfall is ivory tower syndrome, creating models that look beautiful on whiteboards but don't solve real user problems. This happens when modelers lose touch with actual requirements. With requirements driven design, the biggest pitfall is tech debt explosion. Each story adds complexity that compounds with previous complexity, creating an exponential growth in system entropy. Schedule regular refactoring sprints specifically to clean up accumulated complexity. Don't wait until the pain becomes unbearable. Feature factory syndrome is another common problem, shipping features rapidly without understanding how they interact with each other. Teams become so focused on individual stories that they lose sight of system coherence. The third pitfall is short term thinking, optimizing for next quarter instead of next year. This lends to decisions that save time now but create much larger costs later. Always consider the total cost of ownership, not just initial development speed. Sometimes spending an extra week upfront saves months of maintenance later. Let me give you 4 mental models that help you make these decisions wisely in practice. First is the lens intentionality principle. Always ask yourself, is this domain stable, regulatory, or data heavy? If yes, bias towards ontology. If not, start with stories. Most teams make this decision accidentally based on whatever feels familiar, but it should be an intentional choice based on the domain characteristics. Second, the Goldilocks ontology rule. Model the parts that will matter in 3 years, not every conceivable nuance. Neither too little modeling nor too much. This requires judgment about what will remain stable versus what will change. Third, the real narrative test. Every major concept in your domain model should trace back to at least one high value user journey. If you can't explain why a user would care about a particular abstraction, you probably don't need it. And fourth, of course, is the total cost of ownership. Requirements driven design is cheaper upfront but more expensive long term. Ontology driven design is expensive upfront but cheaper long term. Choose based on your actual time frame, not your stated time horizon.